This question is from GATE 2013 Mechanical Engineering paper, question number 15. A steel bar 200 mm in diameter is turned at a feed rate of 0.25 mm per revolution. With a depth of cut of 4 mm, the rotational speed of the workpiece is 160 rpm, revolutions per minute. Material removal rate in millimeter cube per second is. Let's write the given things. So the steel bar has mean diameter. We'll denote this by capital D as 200 mm. Feed rate small f is 0.25 mm per revolution. The depth of cut small d is 4 mm. Rotational speed of workpiece, it's given in rpm, so it is n, capital N, 160 rpm. And we need to find out the material removal rate, mm cube per second. Let's see how this is done. So to find out material removal rate, we can use the formula, standard formula for it, which is feed rate F into the depth of cut small d into the translational velocity of tool, that is small v. Now to find small v, we will use n and capital D. Small v can be given as r into omega. Translational velocity is radius into the rotational velocity. Now omega can be written as 2 pi f. This f is the frequency of the tool. It's not this feed rate, it is the frequency of the tool. And this f can be then written as n by 60, because this frequency is per second. To convert it to per minute, we are dividing it by 60, and we have it given as capital N rpm as 160 rpm. Now let's substitute in terms of what we have. We don't have the radius, we have the diameter. So we can write capital D by 2 into 2 pi n by 60. This gives us V as pi d n by 60. So we can write F into D into V as pi d n by 60. 2 by 2 gives us 1. Pi d n by 60 is small v. Let's substitute and find out the material removal rate. Feed rate is 0.25 millimeters per revolution. Depth of cut is also in millimeters. So as it is, pi into capital D also is in millimeters. So 200 into 160 is revolution per minute. And we have this as millimeter per revolution. So we'll take it as 160 by 60. This, when calculated in digital calculator, gives us material removal rate to be 1675.516 millimeters cube per second. We have three terms with the unit millimeter in it. So definitely when we multiply them, we get millimeter cube, and per second is there with the n by 60. Because it is revolution per minute, we have converted it to revolution per second. Let's go back and mark the correct option. So the correct option is given in option D. Material removal rate in millimeter cube per second is 1675.5. To learn the further details on this topic, you can refer to the NPTEL video, Practical Machining Operations, Turning and Shaping and Planning Operation from the course Mechanics of Machining. This course is by Professor Uday Dikshit. He is from Department of Mechanical Engineering, IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.